Hello all, I am Pradeep. Welcome to my YouTube channel. In this particular video, we'll see basic regression project to understand the basics of keras syntax and adding layer. To learn basic syntax of keras, we will use a very simple fake dataset. In following video, we will focus on real dataset along with future engineering. Let's pretend this data are measurement of some rare gemstone with two measurement features and a sales price. Our final goal would be to try to predict the sales price of a new gemstone we just mined from the ground in order to set a fair price in the market. Here I'm going to begin with a couple of imports. I'll import pandas, numpy and a little bit of visualization cbon as SNS, and I'll import matplotlib as plt. Let's go and read this file. We use read underscore csv to get the data here and the file called fake regression.csv, and we'll check out the head of data frame. The data frame is very simple. It has a price and then two corresponding futures. We are going to treat this as a regression problem where based off future 1 and future 2 will attempt to predict the price, and basically it is the supervised learning problem. I want to quickly show you we could explore this dataset, create a pair plot of a data frame. In this, future 2 has a very high correlation with price. Once you explore your data, the next step is to create the train test split. But before going to train test split, just for your reference, you can see your shape of the data. You have 1000 rows and 3 columns. And now once you explore your data, the next step is to create train test split. We can do this from scikit-learn model selection. It has a train test split functionality which is really easy to use. What we are going to do with this train test split function is to split our data into a training set and test set. We will train on the training set and then evaluate our model performance on the test set. First, what we want to do is we want to grab the future that we are going to use. So in this case, that will be the future 1 and future 2. And because of the way TensorFlow works, we have to actually pass this numpy array instead of pandas data frame or pandas series. So I can simply add dot value to the end of the series and it will return it back as a numpy array. We grab the future and set this as capital X. And the label that we are going to predict our Y is the price column, and same thing here will grab values. Once you can see the difference of X, which is two-dimensional array, so I have given capital X, and Y is one-dimensional array and I have given small y. It's time for our train test split. We split our futures into X train and X set, and as well as our label into Y train and Y set, Y test. So after separating it, you have to choose the percentage as your test size. This is the test size, and here we choose 0.3, that is 30% of my total data set will be used for the test set. Here train test split is going to perform the split randomly, so it's going to grab the random rows and split them into training side and test side, and the number you choose is it's an arbitrary choice. Check the shape of all the futures of the following value. It got split into training and test dataset. So after running this code, you can see the shape for each and every value. So in X train, it is 700 rows and 2 futures, which is future 1 and future 2. Whereas in next test, you have the test data, which is remaining 300. That is 30% of your data. Fine. And this is almost your Y train dot shape, which is your price column. And in training dataset, you have 700, and in test dataset, you have 300. We will normalize and scale the future data. For this, scikit-learn allows us to do this quite simply by using pre-processing and by importing min-max scalar. If you call help min-max scalar, it actually describes what this is doing. Just remove this comment. If you call this min-max scalar, it actually describes what it is doing, and you can able to see some of the examples, and you can get deep down into this min-max scalar when you run this command. Time being I'm commenting it. Essentially, it is going to transform your data based off the standard deviation of the data as well as minimum and maximum value of the data. We create an instance using this. I will fit on xtrain, and what it does is it simply calculates the parameter to perform scaling. We run this fit in only training set, and the reason we only run in the training set is because we want to prevent what known as data leakage from test set. So we only fit our scalar to the training set. Do not try to cheat and look into the test set. Then we transform our training data. It performs transformation. Actually, it's two-step. We fit, which is calculated what's needed for transformation to occur, and then we actually perform transformation, and we will do the same for the test set. And now you can have a look at your xtrain. Sorry, it's small. Just having a look at your xtrain, you can able to see that your data got scaled. And just take a look at your xtrain dot max, that is your maximum value in this xtrain is 1. And take a look at your xtrain min. That is 0. So as we told, what this scaling does is it transform your data based upon standard deviation and minimum and maximum value. It just transformed between 0 and 1. Thanks for watching this video, guys. In this video we have saw how to train your data, how to segregate your data into training data and test data, and how to scale your data. So in the next video I'll show you how to create a basic neural networks and how to predict with the new future value. Thank you so much, guys. Thanks for watching the video. Please don't forget to click like, subscribe and share it. We catch you on next video. Bye bye.